Hello everyone, today we're going to talk about graphing quadratics, specifically in standard form. First we're going to review graphing a parent graph quadratic so that we can get some basic points that we want to look at. So when we have y equals x squared, that is the most basic quadratic we can have, and we're going to plug these 5 points in on the left side for x and see what we get for y. So if we plug in -2, we get -2 squared, which is going to be +4. If we plug in -1, we're going to get +1. If we plug in 0, we're going to get 0. If we plug in 1, we're going to get 1. If we plug in 2, we get 4. And so when we graph these on our graph, we can go -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And that should give us a parabola that looks something like that. And so that's our basic parabola that we have. And one thing we need to notice is our parabola has a characteristic called an axis of symmetry. And so if we draw a vertical line through the vertex, that point or that line the parabola is reflective across both of those. And so what we can do is we can just look at graphing this point. So we need our vertex and then our point to the right, so right 1, up 1, and then this point here at 2, 4, or right 2, up 4. And so if we can graph those will all reflect over across, and you see 1, 1 converts to -1, 1, and 2, 4 converts to -2, 4, and that would give us our parabola. So we really only have to graph those 3 points and then use our axis of symmetry for that. On top of that, we want to think about is at 0, 0, to get those first few points, that's always going to be our vertex. So we will talk about finding your vertex in a minute. And then at 1, 1, if I'm saying give me directions from the vertex to that point, we would say we're going to go right 1 and up 1. And then going back to the vertex, directions to the next point, so that 2, 4, we would say we go right 2 and up 4. And the key to that is that we can graph any quadratic based off of that. The only thing that we will look for is any transformations of multiplying will cause some changes to the up portion, but we will talk about that when we get there. So looking at standard form, so standard form is in the format of ax squared plus bx plus c. And the way we want to find our axis of symmetry and the vertex, because if you notice, these two things are the same, so you're finding the same thing. You don't have to do it multiple times. But you need to plug in -b over 2a. You need to find -b over 2a, and that's your x value of your vertex and the axis of symmetry. And then, so that is this part here. And then if we want to find the y value, all we have to do is plug in our x value back into the function and see what we get. And then another piece of information that you'll be asked is if something opens up or down. And that's basically to tell us how to graph something. So if a is greater than 0, then our quadratic opens up. If a is less than 0, then it's going to open down. So we're going to do a few examples of this to kind of explain what we're talking about. So for f of x equals x squared plus 4x minus 3, we're going to go through an order of these to figure out how we can start to graph these. So you want to find these 3 first before you graph. And so if we were talking about opens up or down, we can see that our a value, there's nothing there, so it's really like an understood 1, and that is positive, so it's going to open up. Next, we need to figure out our axis of symmetry, which if you use the formula on the last page, is x equals -b over 2a. And so that's going to be -4 over 2 times 1. And that's going to end up being -4 over 2, which is -2. So our axis of symmetry is x equals -2, and our vertex x value is -2. And from there we can plug back in and say find f of -2. So we're plugging back into the original equation. So we're going to say -2 squared plus 4 times -2 minus 3 And you can plug that into your calculator and you should end up with -7. What we can do from there is we can now graph our parabola. So we are going to go to -2, -7, put our point, and then we're going to say that we're opening up and our a value is 1, so we are going to follow the parent graph. So we're going to go from our vertex right 1, up 1, and put a point, and then we're going to go back to our vertex and go right 2, up 1, 2, 3, 4 to that point right there. Now we talked about the axis of symmetry is a vertical line that goes through here, and we can reflect that across. And so what that's going to leave us with is a point over here and here. And so now we can graph our quadratic to look something like that. And you can answer the characteristics like we did yesterday for these now that you have them graphed. Looking at the next one, similar kind of idea, but if you notice our a now is going to be -1. So that means that we are going to open down, which is going to change our graphing method, the up and down portion. To find the axis of symmetry, we're going to do the same thing. So x equals -2 is our b, over 2 times -1. The 3 negatives will still result in 1 negative, and we're going to get 2 over 2, which is -1. So our axis of symmetry is x equals -1, and our vertex x value is -1. Now we need to plug back in to find our y value. So f of -1 equals -1 squared minus 2 times -1 plus 1. And when you do that, you should end up with 2. Same kind of deal. We're going to go to -1, positive 2. We have our point. Now, a is greater than 1, or sorry, a is less than 0. It is -1. And so then that means that we're going to open down. So instead of the up portion, we still go right 1 and right 2, but instead of going up, we're going to go down. So from our vertex, we're going to go right 1. Parent graph goes up 1, but we're going to go down 1. Go back to our vertex. We go right 2. Our parent graph goes up 4, but we're going to go down 4 because we have that negative. We can reflect these across our axis of symmetry. It is helpful to draw that in so that you can see. And we're going to have a point here and a point here. And then again, you can answer your characteristic questions once you have graphed it. But you need to find these 3 things first, graph your graph, and then you can go back and answer the rest of the questions. Okay, last example is finding the characteristics of this graph. If you notice, we are different in that we have an a value of 2, so that's going to change how we graph our up portion again because we're not going to be graphing the parent graph. We are going to open up because that is positive, and then our axis of symmetry we need to plug in. So we're going to say -12 over 2 times 2. 2 negatives make a positive. 2 times 2 is 4, so we're going to get 3. So we get x equals 3. And we can start off by graphing that if you want. So we're at x equals 3 just so that we have it and we don't have to do it after we graph our points. And then the x value of the vertex is going to be 3, and we need to plug back in. So f of 3 equals 2 times 3 squared minus 12 times 3 plus 10. And when you work that out, you should get -8. So we're going to plot our points. So we were at 3, -8 is right there. Now, instead of going right 1, up 1, we have to go right 1, up 1 times a, which is 2. So we're going to go right 1, up 2. So we have a point there. And then we're going to go right 2. Parent graph goes up 4. We're going to go all the way up 8. And then we want to reflect those across our axis of symmetry. And then we have this parabola that's been stretched a little bit thinner for there. Okay, so I hope that has helped you graph quadratics in standard form. And remember that you need to always graph these 5 points whenever possible.